Hey everybody, I wanted to post a video of your test remediation for probability, just in case you missed it from class over the last couple of days. Remember that to get your remediation grade, you must have down what I have down, because I'm explaining it here, and then you're going to show the same thing over here to get the credit, okay? For this particular one, these are the most missed from the test. A jar contains pink, white, purple, and yellow jelly beans, and you're given 3 of these probabilities. The yellow one is missing. So it says, what is the probability that the jelly bean will be yellow if a student pulls out one of the jelly beans? Well, the trick here is knowing that all the probabilities add up to 1. The pink, and the probability of the white, and the probability for pulling out a purple, and the probability for pulling out a yellow should add up to 1, as should any set of probabilities of all the events should add to 1. So basically I add these up and subtract from 1. If I add all these up, I get 0.9, and 1 minus 0.9 leaves 0.10. That's the same thing as 1/10. Okay, number 2. Number 2, they're giving us an experimental probability. They're saying we're tossing a coin 20 times, and 5 times it lands on heads. So we're getting 1/4. Okay, now they're saying, well, how does that differ from the theoretical? Remember, theoretical is what we would expect to happen. And theoretical is there's 2 sides to a coin, and 1 side is heads, so the theoretical is 1/2. And basically, the experimental probability is half what the theoretical probability is. So the answer is B. All right, number 3. We spin a spinner 60 times, and here are your experimental results. So again, we need to calculate our relative frequency or our experimental probability. It's the same thing. Okay, and we're going to do that for the blue because they want to know how many times would we expect it to land on blue if we spun it 450 times. So the experimental probability for blue is 14/60, and then we multiply by the 450 times. All right. Rolling a number cube twice is our dice pair charts. So remember we, in the pair of dice worksheet, in the video, we had a bunch of charts for a pair of dice. One was multiplying the dice together, one was adding the dice together, one was subtracting the dice, and one was just what is showing up on the faces of the dice. We know that there's 36 total outcomes in our dice pairs, and they want to know what's the probability of rolling an odd number both times. So in the chart, I have highlighted the ones that are odd. There's 3, 6, 9, where both dice pairs are odd. So that's 9 out of 36, which is the same thing as 1/4. Number 5. We are dealing with 2 number cubes again, so we need another dice chart again. This time, they're talking about multiplying the results of the 2 dice, so I need the chart where we're multiplying. They want to know when we multiply the pair of dice, how many ways can we get an odd number when we multiply? So I have filled out the chart with only the ones that give me an odd number. 3, 6, 9 of them. So there'd be 9 pairs that when we multiply them together, we would get an odd number. Okay, number 6. The probability of winning a certain game is 5/8. That's the probability of winning. The probability of winning is 5/8. If a game is played 500 times, how many times would someone be expected to lose? And we discussed how this probably tripped a lot of people up because it's not the probability of winning. We need to use the probability of losing. So if we took the winning probability and multiplied by 500, this actually tells us how many times we expected to win. So if I wanted to know how many times I would lose, I need to actually take 500 and subtract that 300. Another way is, if the probability of winning is 5/8, then that means the probability of losing is 3/8 because they all have to add up to 1. So I could take the probability of losing and multiply by 500 as well. All right. Number 7. Spinning 2 spinners. This is a compound event. We have 6 outcomes for spinner 1, 4 outcomes for spinner 2. With the counting principle, we multiply those together to get 24 total outcomes. And then on top, we want the favorable outcomes where we land on a 4 and then we land on a blue. There is only one way in our sample space to have a 4 and a blue. So 1/24 is the answer to this problem. Number 8. We are selecting a card and spinning a spinner. This is a compound event. I need a box for the cards, box for the spinner. There's 2 outcomes for the cards. There's 1, 2, 3, 4, 5 outcomes for the spinner. When I multiply those together, I get 10 possible outcomes. We know that the total possible outcomes goes on the bottom of the fraction. Now, the top of the fraction are the favorable outcomes. Well, what are the favorable outcomes? That we select an X and the spinner lands on a number greater than 6. So the spinner lands on 7, 8, or 9. So in my sample space, that would be an X, pulling an X and getting a 7, pulling an X and spinning an 8, pulling an X and spinning a 9. There's 3 favorable outcomes. That's what goes on top. 3/10 is my probability. All right, and then the last one. Maria has 2 boxes of colored markers. She is going to draw from each box, so that's another compound event. She's drawing from one box, then the other box. One box has 3 markers in it. The other box has 3 colored markers in it. When I multiply that together, I get 9 outcomes. Okay, this time I chose to do a tree diagram just so you could visualize. So again, the bottom is going to be 9, but we want to know the top part is the favorable. Well, what is the favorable? That we choose a blue, then an orange. So here's my tree diagram. Here's the first box. It's got red, blue, yellow. The second box has purple, pink, and orange. And the only way to do blue, orange is one way. So that would be 1/9. All right, folks, y'all have a good day.